Okay, everybody, we're going to give everybody a couple of minutes to jump on board here, and then we will get started on our next webinar on strategies in science safety. Hey, folks, we're going to give it about 2 more minutes, let everybody jump on board here, and then we'll get started on our webinar. Thanks so much for taking the time out today to join us. I appreciate it. Okay, about 30 more seconds, and we will get started on our webinar today. All right, we're going to go ahead and get started. First of all, thank you all for joining. I'm Becky Anderson. I'm located in Des Moines, Iowa. I've owned a consulting firm for about 16 years, and prior to that, I was at a HHW facility, and then I've also worked in industry. I've also been a volunteer firefighter and have worked closely with my local emergency response community for quite a long time. And in Iowa in the early 2000s, helped build a program called Rehab the Labs. So I've worked with schools and chemical challenges in schools for a really long time. I'm actually a hazmat chemist, and I've done some, quite a bit of bench chemistry and that kind of stuff too. So we'll start today just with a quick thank you to EPA Region 1. They've provided the funding for this, and we very much appreciate it. Also, a little shout out to Vicki Davis at the Upper Valley Lake Sunapee Regional Planning Commission. Vicki's the one that obtained the grant and has been coordinating and working with a lot of schools in both New Hampshire and then helping out and coordinating with some Vermont personnel as well. Vicki's been a great asset. If you need anything, have any questions specifically about disposal options, anything like that, Vicki is a great resource for you. And then just another quick shout out to Dave Waddell. Dave Waddell started the Rehab the Lab program in King County in Washington State many years ago. He's my mentor in this industry and in cleaning this kind of stuff up. And he's now retired, but he has built some fabulous resources for us and has provided us with a lot of photos and a lot of experiences to help us train and make sure that we're cleaning all these unwanted chemicals out safely. The goals for these webinars this series of webinars is to make sure that we're evaluating risk in schools, making smart decisions about what chemicals we want to keep, identifying and disposing of legacy chemicals, which are those chemicals that have been sitting around for a really long time, and then work really diligently to make sure that we're finding good solutions to teach quality science, while at the same time continuing to keep students and teachers and everybody else in the building safe. We have seen some accidents over the last few years, and in a couple of webinars, we're actually going to be talking about that, keeping students safe in the science lab and what the risks are that we've seen. So next screen here is just a few technical tips from EPA for this Zoom webinar that they are hosting. At this point in time, you can't or you won't be able to enter anything into the chat. But if you do have any questions or comments, please put those in the question and answer box. I will try kind of as we're going along to answer questions. If it requires a great deal of thought, I might have to wait until the end so that I can focus on the topic at hand, and then I'll address that at the end. We also will have 30 minutes dedicated at the end of this to any additional questions or guidance that you might want to send over, and I'm happy to help answer whatever questions I can. If there's something specific that I don't know the answer to, I'll make sure that I get your contact information. I'll reach out to you and make sure that you have the right answer. Closed captioning is available for this. The raise hand is disabled, so please put any comments in the question and answer box. And then also, if you're having troubles hearing me or with any sound or anything, there is some troubleshooting guidance there as well. Let's see, topics for today. So we have already talked about what legacy chemicals are. We've identified the super dangerous ones that we need to leave sitting in place till we have a good high level disposal plan. And we've reached out to some professionals that know how to get rid of these safely. We also spent a lot of time talking about minimizing chemicals, that there are 4 criteria you can use to minimize chemicals in your stockroom. One is you want to make sure that the age of the chemical is within the last 5 to 10 years. We don't want anybody using anything that's really old. Chemicals just aren't designed for that. We also want to look at the quantity of chemical that you're keeping on site, whether or not the containers are damaged, and then make sure that they're not on that dangerous where the risk exceeds the utility list. I have had some questions about, are these webinars going to be available to you to access? I have a meeting with my web guy next week. Everything right now is out on a YouTube channel, and it's just a matter of connecting those links to my website. So we'll get that finished up hopefully next week, and then alert you that you will be able to access the webinar information. I'm also building a resource pool for you that will be out on the website as well. It will be the same website that you used to register for these webinars. In addition to identifying chemicals to minimize, then we spent a lot of time talking in one of our seminars or one of our webinars about classifying chemicals, sorting chemicals by classification by hazard class and storing them safely that way. And then we've also started identifying different things in our classroom that we need to make sure are in place for safety purposes. We've developed, or I've encouraged you to work on developing an inventory of your chemicals, identifying the different safety measures that are in your classroom, things like safety showers, eye wash stations, safety glasses, all of those types of things. All of those different things that we've covered over the last few webinars, many of them are going to be key components of your chemical hygiene plan. And so that's what we're going to focus on today is, what is the chemical hygiene plan? Who has to write it? All the different challenges associated with the chemical hygiene plan. And I will tell you, it is a big document. It's a tough challenge to get one implemented, and there are a lot of requirements in order to meet the OSHA criteria for the chemical hygiene plan. We'll go through that today, and I'll give you some strategies that I think have worked over the years as I've helped other schools implement a chemical hygiene plan. So that's what we're going to talk about. What is a chemical hygiene plan? Why do you need one? What are the required sections of it? And then how can we be most efficient at writing one? And Molly asks, is there a template for a chemical hygiene plan? There is. There are several out there. One of the best ones is out on the Maine. If you Google, I think it's Maine Lab Packs. And Bryn, I thought I saw that you were on, but Bryn, if you could tell me what the website is for that Maine chemical hygiene plan, that is the best one that I found. So Molly, there are some available. If we don't get an answer on that, I'll see if we can find one and send that a copy of that template over to you. The Maine one is the easiest, most comprehensive one that I found. There are some other ones that I'll refer to, but there are absolutely, the main one is really one of the best ones that I've seen. So we'll talk more about that as we go through this. All right, final housekeeping tips. Please make sure that you're posting any questions. I'll try to get to them through the presentation. And also please keep in mind, especially as we put these webinars out on the website, that this is information that's being presented in 2024. It is current information based on the conditions and the regulations that we know are in place right now. I will tell you, I've been doing this for 25, almost 30 years now, and the regulations change sometimes. Best practices change. As we grow and as we learn more and more the risks associated with chemicals, or more and more strategies to keep students and teachers safe, this guidance will change. It has changed over the past 25 years. So please keep in mind, if I've got somebody watching this in 2042 or something, that this was designed for information that was current in 2024. And then you've got my little disclaimer on the bottom of that too, that says, you know, if I screw anything up today, I'm really sorry. I'm working very hard to get it all accurate and complete and correct for you. But I am only human, and I do kind of screw things up every once in a while. So hopefully that's not today though. Okay, so we're going to summarize where we're at now. We've looked at the hazardous legacy chemicals. I'm going to go ahead and stop my video, and then we'll just focus on the presentation video. If anybody's having any trouble, shoot a question in on the question and answer page, and we'll see if we can get you helped out. So far we've looked and we've recognized and assessed those high hazard chemicals. Again, these are the ones that we leave in place and we ask for expert guidance to get rid of. This is the old cans of ether. This is tetrahydrofuran. These are peroxidized containers of potassium and sodium. There's a whole slew of those that we want to make sure that we are recognizing and leaving in place. We've also prepared a map of your classroom, an inventory of the chemicals that you are going to keep and that you use. And we've assessed those chemicals to make sure that they're in good, solid, undamaged containers. They're not more than 5 to 10 years old. They haven't been contaminated. They are not degraded. They're not in excess quantities. So all of those things have gone into consideration as we've identified chemicals that we are going to keep. And then once we identify those, we classify them according to chemical hazard class. And we talked about that during our last webinar. As you've built that inventory, one of the other things that I want you to be mindful of is, what is the personal protective equipment that is required to work with this particular chemical? What are some of the engineering risk minimization strategies? For example, if we're working with methanol, the safety data sheet for methanol says very clearly on it that we should not be breathing that stuff in. So if we are going to work with methanol, we want to work with it under an operating and inspected fume hood. We want to make sure that our fume hood is drawing those vapors away from us. So we might need to work with our facilities person to check that out, make sure that's working correctly. We've also prepared instructions on each of the different labs that we've completed. And hopefully you're now starting to develop that disposal plan. So the chemicals that are sitting on the shelf that you no longer want, they're outdated, they're in containers that have been compromised, or the risk of having those chemicals on site exceeds the utility. All of those things then help you generate a list of things for disposal. Now, one of the things that Maine Lab Pack has offered to do is come in and assist in evaluation of those chemicals for disposal and offer you a disposal quote on those. And I would encourage you to take advantage of that. They're a top-notch company. They've supported schools in the area in the Northeast for several years. And all of the discussions that I've had with Bryn and Mitch at Maine Lab Pack have just been outstanding. All right. So let's jump into this chemical hygiene plan. You already have a number of sections of the chemical hygiene plan completed. Again, you've got that map of your classroom, the inventory of your chemicals, a disposal plan of how you're going to dispose of things, and SOP or procedure for how you're evaluating chemicals on whether they need to be disposed of or you can keep them. All of those are key parts to the chemical hygiene plan. Okay, first thing we're going to jump into is, why do we even need to do this whole chemical hygiene plan? And frankly, chemical hygiene plan, just the name of it it's scary. And I have thought for years, it just sounds exhausting. Sounds like it's going to be a lot of work. Okay, I'm here to tell you that because of the resources that we have out in templates, because of those resources, it's not as difficult as a task as it was many years ago. Okay, so we're going to provide you with some guidance on what are the key sections that you need to have, and then I'll encourage you again to go work with Maine Lab Pack to identify the main. And I believe you can just go to Google and type in Maine Chemical Hygiene Plan schools, and it'll come right up. There'll be some examples that come right up. So the two sections of regulation that oversee and require this, there's really kind of two of them. One is the OSHA General Duty Clause, and the General Duty Clause is invoked when OSHA can't, when there's been an accident or an injury that's occurred, and there isn't anything specific that OSHA code states that, hey, you shouldn't do this, it's dangerous for you. So what we see here in Iowa and what I've seen throughout the US is that if we do have an accident or an injury, OSHA can come to the table and say, hey, well, this was a violation of the General Duty Clause, because if there's a risk, even if it's not a required program, a business is required to protect its workers, okay? Teachers are sometimes covered under the OSHA requirements if they are not covered by an OSHA state program. So for example, New Hampshire does not have its own OSHA state program. Vermont does have its own OSHA state program. Okay, so in Vermont, you're covered by the General Duty Clause. In New Hampshire, there's no state OSHA, but you are covered by the federal General Duty Clause. So just because the state doesn't necessarily have it and you're not required to do all of the things that OSHA says in New Hampshire, you are covered under the General Duty Clause of that federal requirement. More importantly are the two standards that kind of join together to create this requirement for the Chemical Hygiene Plan and the components of the Chemical Hygiene Plan. The first one that we're going to talk about is what's called the OSHA Lab Standard. And the place that you find that is in the 29th Code of Federal Regulations, section 1910.1450. That is the section specifically that addresses lab requirements for labs, for academic labs, okay? And this is where, in this section of code, which is, it's directly applicable to Vermont, New Hampshire, I'll get to you in just a minute, but directly applicable to Vermont, it says, the OSHA lab standard says you have to have a chemical safety officer identified. You have to develop a chemical hygiene plan. You have to have an inventory of your chemical safety data sheets and several other items. We're going to go through those other requirements. Schools in Vermont are subject to the lab standard. The really interesting thing and the hard thing to wrap your head around, though, is because this is the lab standard, a chemical hygiene plan is only required for science labs. So this doesn't apply to art or facilities or bus barns or industrial tech. However, because we also have the OSHA General Duty Clause, many of the requirements in the lab standard do kind of overlap with what the requirements would be in other areas of the school. The lab standard specifically in Vermont is only for academic science labs. The other, and in New Hampshire, hold on, I will get to you, I promise. Now, the other section that is very applicable to this is the OSHA Hazard Communication Program. This is a different set of regulations. It's found in 29 CFR 1910-1200. That is the section of code that requires you to have safety data sheets, to label things properly, to use pictograms, to have chemical risk training in understanding how to read safety data sheets. And it also requires a written program for how that process is going to be implemented in the facility. The OSHA Hazard Communication Program is all areas of the school are subject to the OSHA Hazard Communication Program. That is a facility-wide requirement. And again, that's directly for New Hampshire. Or excuse me, I'm sorry, that's for Vermont. So in Vermont, we have the OSHA lab standard that's targeted at science labs. We have the OSHA Hazard Communication Program that is targeted for the entire facility. And I know it's confusing. I apologize. I'm going to try to really clarify for you what your responsibilities are. Okay. Next one is we're going to talk about if you do not have an OSHA state program. And that would be the case in New Hampshire. So what we've seen is that even though the federal OSHA code is applicable to New Hampshire, you don't have a state agency that's enforcing it. So I'm sure that there are some people that would make the argument that since we don't have OSHA, we don't have to have a chemical hygiene plan. Since we don't have OSHA, we don't have to pay attention to the hazard communication program. And that's not true. What has happened in New Hampshire is that even though you have no OSHA program, the Department of Labor and the Department of Education have stepped in and said, you know what, we think these programs are important enough that we're going to adopt them and enforce them. So Department of Labor has adopted the OSHA Hazard Communication Program. The HAZCOM standard, again, requires you to have an inventory, safety data sheets, proper labeling, right to understand training in a written program. The Department of Education has taken this kind of one step further as well and said, you know what, we're going to adopt the OSHA lab standard, including the chemical hygiene plan, and enforce it. And these are very recent changes to administrative rule. They just happened in October of 2023. And if you want to read that, you can look in New Hampshire. If you Google New Hampshire Administrative Rules, Part ED 320, Part ED 320, and that will come up right away. The other interesting thing with New Hampshire is that they have expanded the information, or they've expanded the requirement to include not just science labs, but also automotive shops and places where hazardous liquids or open flames are frequently used. So New Hampshire, I hate to tell you this because I have a lot of folks in New Hampshire that think, well, we don't have OSHA, so we don't have to have a chemical hygiene plan. We don't have to worry about safety data sheets. That's just not the case. Both of those OSHA requirements have been adopted by other agencies, either Department of Labor or Department of Ed. So what this boils down to is New Hampshire and Vermont, both of you are subject to a hazard communication program, which means you need to have SDSs, you need to understand how to read them. And then you also are subject to the OSHA lab standard, which requires you to have a chemical hygiene plan and all the components along with it. Now, in broader terms, we're going to step back from this requirement just a little bit, okay? And this is one of those things that I cover a lot with our, are you guys seeing this okay? Rosa, can you just verify for me that the screen is changing correctly?
Yes, you're on the slide that says, what is a
CHP? Okay, just wanted to make sure. I've got a couple of screens open here, so I wanted to make sure that, that I was actually showing you the correct one. So, okay. So we're going to talk about, just step back just a little bit of why do you even need a chemical hygiene plan? And what I know that schools are tasked with so many things right now that adding this one more thing to the requirements of everything else you do it's got to be overwhelming. I understand that completely. What I'm going to tell you though is I think it's really important, not so much that you have a perfect written plan. Okay, we want a plan that meets the requirements, that covers and addresses all of the information that is required by code. I don't want you getting into trouble with any regulations, okay? But more important than that is the exercise that you go through to build that chemical hygiene plan. And the reason that we want to go through that exercise is it helps to improve understanding of where the risk is, and it helps you to build plans and have discussions with your other safety committee colleagues on what are we going to do if. And this is an exercise I've taken a number of my industrial customers through. And these are statistics that we've seen for over 120 years. And we call this the science of safety. And what we've seen is that Anytime we're working in a facility, doesn't matter if it's a school or a giant manufacturing plant, the more near misses, the more injuries and the more accidents that we see that happen at that facility, the more likely it is that we're going to have some serious accident happen and potentially even a fatality. It's almost like we take all of those at-risk behaviors and we throw them into a funnel. Well, after a while, the more that of those accidents, incidents, near misses, and injuries that we throw into that funnel, the more likely it is that something really bad is going to happen. Building the chemical hygiene plan gives you the opportunity to coordinate and work together as a safety team to begin to identify, okay, where is the most risk in my school? How do I fix this? And what is my plan if something goes sideways? OSHA also has, and this is emphasized throughout the United States by OSHA inspectors, OSHA has what's called a hierarchy of controls. And basically, this is just a strategy list for how do you minimize risk. The first thing is if we determine that something has a high level of risk, can we eliminate using it or substitute something that's different? So for example, I really like doing glass etching. Okay, and I don't really know very much about it, but I think it's pretty cool. Glass etching usually uses, or in the past has used, a chemical called hydrofluoric with an FL, hydrofluoric acid. Hydrofluoric acid is wicked bad. It's a calcium scavenger. It does permanent tissue damage if you splash yourself with it. It's just a very, very dangerous chemical. Well, I like glass etching, but I really don't like the risk with hydrofluoric acid. So is there an alternative that I can use that eliminates the risk, or a substitution that I can do instead of hydrofluoric? Is there something else? And there are some alternate chemicals that are available. They're still pretty dangerous, but they're less dangerous than liquid hydrofluoric acid. The next thing I'm going to do is go, okay, I like etching. However, it's pretty dangerous. I really don't want to sniff the vapors. I don't want to have my students sniffing the vapors. Is there some place that I can do this that I'm not exposed to those vapors on a regular basis? But remember, you as teachers, you guys are in there a lot longer than your students are. Oh, and my students are subjected to those. Well, yeah, we could do that etching under a fume hood where all of those vapors are drawn away from us. And then the last step that we want to think about is personal protective equipment. And the way that I explain personal protective equipment to my industry folks when I'm training them is, you know what, this is one thin piece of plastic or nitrile or something between you and something that's really going to hurt you. So that's kind of our last ditch approach, is what personal protective equipment can we use? If I'm going to work with something that is an alternate, safer substitution to hydrofluoric acid, I'm still going to use chemical resistant gloves. I'm going to want to make sure that my arms are covered and my feet are covered so that if I have any splashes, I don't burn myself. And I'm also going to make sure that I have safety glasses on. And if I don't have a fume hood in my art room, I'm going to go down and sweet talk my science teacher into using his or her fume hood, if at all possible. And that way we can minimize that exposure. So thinking that way through that elimination of risk and the hierarchy of controls, once you start evaluating the procedures and the labs that you're doing, you're going to start seeing some common themes about, okay, what are the things that we can do to further minimize risk? Do I really have to do this experiment with everybody having 500 mils of methyl ethyl death? Or can we do it as a small scale experiment where we're just working with 2 mils? Is it possible to do that? The other thing is what we'll find is a chemical hygiene plan, even though a lot of the information is targeted at science labs, much of the information is anywhere chemicals, it is important to identify anywhere chemicals are used. So labs are called out by OSHA lab standards, so that would be required in Vermont. In New Hampshire, there's that quote from the new language that was just passed in October. Chemical hygiene plan is required for anyone with science lab, automotive shops, and any place where hazardous chemicals, hazardous liquids, or open flames are frequently used. So that could also be your art department. That could be your industrial tech. The best strategy to meet the chemical hygiene program requirements, and these are the ones that we're going to talk about in the next few slides. The best strategies for meeting those are to work with representatives from each department that is subject to that, and to build a team so that you can coordinate your effort and yet still minimize the burden on individual people. I have been in schools before where when we've identified that a chemical hygiene plan is needed and needs to address the entire school, not just the science lab, a lot of times the science teachers, the department chair still gets tasked with writing that chemical hygiene plan. I'm going to encourage you that you divide up that chemical hygiene plan into sections and you have the committee pick sections to write so that the burden doesn't fall on one person. The chemical hygiene plan that we have to put together does need to meet the requirement of the law, but again, it's more important for you as you're going through writing that chemical hygiene plan for you to start evaluating risk, looking at things a little differently in your classroom, looking at things a little differently in your school, and then preparing. Okay, we recognize that we've got people down working with soldering irons and solder in industrial tech, and they're learning how to solder things. Well, shoot, has anybody looked at the flux or the solder to make sure that it's meets safety standards? Are they using personal protective equipment so they don't end up burning themselves? Do we have a process in place that says, hey, when you're done with the soldering iron, you need to set it over on a safety stand so that nobody bumps into it or burns themselves? So those are the types of things that we want to address. It enables the evaluation. The chemical hygiene plan enables evaluation of a lot of processes by the team to determine if risk exceeds utility and also to identify then where are the problem areas. And that's really critical. And the longer that I do this, the more I want to encourage you that more eyes on this is better. If you can work as a team and identify some people to assist you with writing the plan and have everyone review different areas, you're going to get different perspectives on whether or not we've got risk. And what I see a lot of times is we'll have a teacher or two that has done the same procedure for 25 years. And somebody new will come and sit on the safety committee. And then all of a sudden it'll be like, that seems to be a really risky thing. Is there something we can do? Is there a way that we can do this that minimizes that level of risk and that level of threat? The other thing is by developing this chemical hygiene plan and building out some of these procedures, it shows due diligence and it shows you have evaluated risk and you are actively working to try to minimize it. If there is an accident or an event in your school that results in injury, it is likely that you having that documentation will be very beneficial to you. Now, I am not a lawyer. I don't know all of the regulations and rules requiring things like that. But I do know that in the schools that I've seen that have this documentation in place, they have had an easier time if they've had all the documentation when they have an incident or an accident. Now, does this mean, I always get the question of, okay, well, as we're going through and we're doing this risk assessment, well, what the heck? Does that mean I'm only going to be able to use vinegar and baking soda? No, absolutely not. I am a bench chemist. I'm a scientist. I've used chemicals, my entire adult career and all through my education. We need to teach students how to do these things, how to use these chemicals, how to complete these processes, and we need to teach them at the same time we're teaching them skills on how to use on what the chemicals do. We need to implement and teach them the safety skills also. By preparing this, by including this in your lab notes and in your initial discussions with students when before you start a lab, by including statements about how we're going to do this safely, how you're going to protect yourself, your fellow students, and me, the teacher, that's going to help even further prepare your students when they move into science careers or when they go to universities for teaching or for learning and furthering their career in science. It's really, really, really critical. There's been an enormous push the last 10 years to improve safety at universities. And one of the things that we are seeing is that high school students are now coming into universities with a higher level of expectation of science safety than they have in the past. And the colleges and universities are now, the vast majority of them are very, very focused on including safety strategies into their education programs as well. Okay, let's jump back into this chemical hygiene plan. So it's a tough document. We're going to go through a number of different programs and parts of it that are required. And I'm going to encourage that instead of just focusing on a chemical hygiene plan for your sciences, that you take a bigger, higher level approach and you build this for your entire facility. OSHA lab standard is more robust and detailed, but it's very focused on science. I've said that. And New Hampshire DOE is much more broad scope than just the chemical hygiene plan. So New Hampshire, you have to do this. So strategies for getting this done. First of all, many universities have posted their chemical hygiene plans online. I apologize. I thought I had the citation in here for the main example of a chemical hygiene program. That's one of the best ones that I've seen. So if you type in, Maine chemical hygiene plan for schools, it comes up right away on Google. If that one is one that you don't like, you think it's too long, it doesn't cover your needs. A lot of universities have their chemical hygiene plans. This is not something you need to reinvent the wheel on. Certainly, it is acceptable for you to pull down one of those chemical hygiene plans and make it applicable to your school. Now, one of the things that OSHA does is they will require that it's site specific. It is specific for your facility. So make sure that, if names are put in there that you put, and I would encourage you to put titles in instead of names because we do see a lot of turnover. But you evaluate that and make sure that it's facility specific for you guys. One of the other strategies that I've seen is that the required elements of a chemical hygiene plan are developed by individuals. So we divide it up. We conquer and divide up that chemical hygiene plan requirements, all those different pieces and parts. But we do have one chemical hygiene officer that oversees the completion of that. That chemical hygiene officer does not have to be your science department head. It can be a facilities director. It can be a vice principal. It can be, I've seen it done a whole slew of different ways. So as you are pulling together your chemical hygiene team, that's one of the things that you'll need to identify is who is your chemical hygiene officer. And that's actually required as a part of the code in Vermont. New Hampshire, I can't remember specifically if they called out a chemical hygiene officer. I believe they did. All right, so let's talk about what are the different parts of the chemical hygiene plan. First of all is scope and application. You want to define upfront who is going to be covered by the chemical hygiene plan. Are you writing this just for the science department to meet the Vermont standard, or are you going to write this for your whole school, your whole facility? I would encourage you to make it broad scope just because then you can pull more people to the table and ask and have more eyes on certain processes and procedures that may present risk so that you can get some ideas on how you can mitigate that risk. Section 2 is responsibilities, and this goes through, okay, who is specifically required to participate and build the chemical hygiene plan? Who's responsible for enforcing this? And then who is going to be your chemical hygiene officer? One of the things that the code states in New Hampshire and also in Vermont is that the chemical hygiene officer has to be qualified by training or experience. One of the things, this gets really confusing, and I did a bunch of searching around to see if there are any specific classes for chemical hygiene officers in school. And I have not been able to find anything that is a course requirement or a certification or anything like that. If this is something that you are interested in, if you could either email me and let me know, or put a comment up in the question and answer. I would like to get an idea of who is interested in more understanding about the duties of a chemical hygiene officer. And then also in some of the training that will help assess risk as you're looking throughout the entire school. Okay, the next section is chemical hygiene officers' responsibilities. And these are all of the specifics that OSHA lists for responsibilities. They oversee the development of the chemical hygiene plan, ensure that the safety data sheets are collected and reviewed, coordinate with administration, and develop safety policies and procedures. One of the primary things I think that chemical hygiene officers do is they do walkarounds. I'm not going to call them inspections. I think that word has a lot of really negative ramifications. So in industry, we call them walkarounds. And what that means is that we have a list of things that we want to look at, and that chemical hygiene officer just walks around and evaluates, are we doing things as safely as we possibly can? One of the challenges with the chemical hygiene officer is that they are challenged and responsible for maintaining an inventory. Well, I'm going to tell you that even though the chemical hygiene officer's name is on that and they are responsible, that really takes and requires a team effort. Because if we have chemicals that are being used in art, we have chemicals that are being used in industrial tech, we have biology, we have chemistry, we have physics, all of those different chemicals need to be included. They don't have to be all in one chemical inventory. We can have chemical inventories for each area. That's not a problem at all. But we do need to know what chemicals are present in the school. Teacher and staff responsibilities that are defined in the chemical hygiene plan include supervising use of activities, reporting incidents and safety concerns, and then coordinating procurement of chemicals. So if you're going to order a new chemical or start a new process, coordinate that with the chemical hygiene officer to make sure that we aren't introducing any unanticipated risk, or that we don't have any, for example, PPE requirements that maybe haven't been addressed and that we need to address differently for a new process. Student responsibilities are to read, understand, and follow a student safety agreement. In a couple of webinars, we're going to be talking about the specific strategies you can use to keep students safe in art, in science, and in industrial tech. And we're going to talk in depth about what needs to be included in that student safety agreement. And is that just with the student, or is that also to be signed off on by parents? And we'll talk more about that again in a couple of webinars. But one of the things that I want to encourage you to think about is making sure that the parents of the students are also aware that there's a safety agreement. The students need to commit to it and the parents need to commit to it. And I know that's very, very difficult. Section 3 of the chemical hygiene plan addresses information and training. So it basically says where the chemical hygiene plan is going to be located. It goes through permissible exposure limits. So what are we evaluating on that safety data sheet to make sure that we're not bringing in something that is more, that presents more risk than utility in our classroom? It also establishes a procedure for employees to recognize signs and symptoms of exposure. This is a big deal. So if you as a science teacher, if all of a sudden something happens, somebody knocks a container of sulfuric acid off of a counter, and as you're cleaning it up, you have symptoms of exposure, you need to recognize those, and then you need to document those. And there needs to be a specific program that's included in the chemical hygiene plan that says, okay, what do we do if we have a student or a teacher that has an exposure? What are the steps that we take to make those people safe and to get them any help that they need? One of the things that I also talk about with employee training is what's called demonstration of competency. It's a phrase that OSHA really relies upon a lot. And I want you to keep that in mind as you are focused on building any type of employee training for other colleagues, or if you are on the chemical safety committee and you're going to build chemical hygiene plan training for your facility. Demonstration of competency, the way that I handle that is I do a pre-test and then I do a post-test. And that gives me a picture of what did my students come in with as far as education, and have we improved on that? I keep those results, and if we do have an OSHA inspection or we have an accident or an incident, that's one of the things that I'll pull out and say, well, we did do training and the training was effective. We went from a pre-test score of 65% to a post-test score of 98%. And these just have to be short little quizzes. I usually do 10 questions. Topics to include in training include how to read safety data sheets, how to use engineering controls, things like fume hoods, elephant trunk fume hoods, any type of personal protective equipment. And then the other thing that's in this section is lab procedures. And we typically, we include those in an appendix or we reference them. So we say, okay, lab procedures for chemistry are located in each teacher's file, or however your school handles that. Section 4 addresses safety data sheets. And this is in your chemical hygiene plan. So it reverts back to or references back to the hazard communication program. And basically what you just have to define here as part of the chemical hygiene plan is, where are the safety data sheets kept? Who is responsible for each area? And again, we don't have to have one person responsible for all safety data sheets. You can say, you know what, each department chair is responsible for maintaining their own safety data sheets, and they're located in this for physics and this for chemistry in this area. So you can define it on an area by area basis. Section 5 goes through the labeling requirements that you implement. And again, this is another part of HAZCOM. So we can just take and reference this back to HAZCOM and say, hey, according to the hazard communication requirements, we're making sure that everything has to be labeled, and it has to be labeled with the components that are, or the elements that are required on the label according to OSHA. Section 6 are standard operating procedures. And this section is going to address procedures for things like procuring chemicals or procuring new equipment that needs to be evaluated for safety. It should discuss the standard operating procedure or show a standard operating procedure for how are you going to store chemicals, that you're storing them by chemical hazard class. You're also going to put in here lab equipment maintenance, spill kit contents, disposal of glassware. How are you doing that? And then also personal protective equipment expectations. So at what point are you going to require students or anyone in a classroom to have safety glasses on? At what point are you going to require people to have long sleeve shirts, long pants, closed toe shoes, and a chemical resistant apron? One of the other things that we can also include in this standard operating procedure is where those safety data sheets are going to be found. I know I talked about that briefly in the safety data sheets section, the prior section. And I've got a question that says, should safety data sheets be at the main office so the fire department and other emergency responders can get at them right away? Ideally, we would like to have an electronic database that's accessible by all the either personnel in the office and all the classrooms. I'm also a big believer in that each classroom should have paper copies of their own safety data sheets. I think it would get a little overwhelming to have them all in the main office, but I think to have them in each department would probably be acceptable. If that is something that you can include in your main office, that would be ideal that way when your emergency responders come in, you're already able to pull that information. However, I would put the majority of the responsibility on those departments. So I'm sorry, there's no clear answer on that. Section 7 is going to cover criteria for using control measures. So this is going to be like, okay, we have a fume hood in chemistry. We have it inspected. It's required on this frequency. This is the person or the company that comes in and inspects it. And this is the CFM, cubic feet per minute, that the air exchange rate is kept at or is monitored at. So these are the specific criteria for your fume hoods, your safety showers, and any of your personal protective equipment should be included in this section. Section 8 also covers safety equipment, and that's where I would put the map of what is prevalent or what's present in your classroom. That's where I'd put the safety map in your classroom. Section 9 is going to cover things like housekeeping, maintenance, and inspections. This can be a very short section. Basically just defines, okay, what are the housekeeping processes? Simple things that can be included in this would be things like, hey, we don't put any broken glass in the standard trash because we want to protect our custodial folks. So we have a box for collecting broken glass. The box has a liner in it in case any of the glass has any liquids that are leaky or gooey. So we know that in each of the rooms where we're using glassware, we've got a glass collection box and we've got it lined so that we're not having any inadvertent exposures or dangers for other personnel. Section 10 is required approvals. And this is kind of an interesting thing. This is an interesting section. I don't see a lot of school districts that have implemented procurement plans or evaluation of what teachers are ordering. I'm going to encourage you to do this. I really think that before we just have free reign on what to order, that we should have a committee that or a number of personnel that evaluate what's being ordered. Particularly if we have a lot of staff turnover, if we have new staff coming in, and before they can just order in everything that they're going to need for the year, I think we need to have some risk assessment there. That would be one of the required approvals that you might consider. And then section 10 or section 11 is additional protection for work with particularly hazardous substances. There's a specific list of the most dangerous chemicals that OSHA refers to typically. Defining though what particularly hazardous substances are can be really tough. So you're going to need to develop parameters around defining those. What is the hazard level that you want in your class or in your school? Examples of these that fall under what OSHA typically refers to as particularly hazardous substances include things like concentrated acids and reactive chemicals like oxidizers, things that could light other things on fire. Section 12 is emergency response and chemical spills, and it just defines, okay, what are you going to do if this happens? And this is the section that I think really is important for a safety committee to discuss and identify all of the pieces and parts of. This is also where we have discussions about, okay, I'm going to be working with a lab next week, and maybe it's department level. And our AP chemistry class is going to be working with a lab where they're dealing with concentrated nitric acid. Okay, bad stuff. We don't want any exposures. We want to make sure we're using it under a hood so we don't have any inhalation exposure. We also want to make sure that we're using chemical resistant gloves and aprons, safety glasses, whole deal. It's a pretty risky chemical. So all of the things that we're going to do would be listed in your procedures. But then as you sit down and talk with either your department or your safety committee, what would we do if that nitric acid container spilled, if it broke, if it was sitting on a counter and everybody was supposed to take a dropper full, and I turned around after 15 minutes and the entire bottle was gone, and I don't know where it went. Those are all the things that I would encourage you to talk through. Typically, we can refer also to the district-wide crisis plan. All school districts have crisis plans in place. These are more down in the weeds, nitty-gritty instances of what is going to happen if I'm dealing with this particular chemical in a classroom. In industry, when we do this, we call them tabletop exercises. They are very, very valuable for you to do as a team. And I would encourage you, what I usually challenge my industry folks is identify the 3 top riskiest things that you do in your classroom with students. And then let's sit down and brainstorm what we can prepare, what we can implement, what we can change before we have any incidents. And then let's also talk through, okay, what are we going to do if the worst of the worst happens? Those tabletop exercises, what they do is they allow you to expand your understanding of risk. They also kind of build these neural pathways that start you down an understanding of, okay, anytime an emergency happens, this is my process that I'm going to go through. First, I'm going to do this, then I'm going to do this, then I'm going to do this. And when we build those processes in our brains, if a real reaction or a real bad situation does occur, I find frequently that anybody that practices these has a much, much better outcome. Records, this is going to be things like, what records do we keep? This would be training records. This would be safety data sheets. Signs and labels, we're going to go through and build and this is the same as what we would have in our written hazard communication plan. How are we going to label things? How are we going to make sure that we're indicating risk to those people that are working with that chemical at a glance? Section 15 is your waste disposal. This is another area that I think you need to work as a team to identify. Frequently, I find that this kind of gets dumped on the facilities manager or the facilities director. And I think that's really a bad plan, because our facilities personnel pretty much don't understand the risks of the chemicals that you're using regularly. They aren't in the science lab. They're not in the art room. They're not in industrial tech. So I think it's a responsibility for each of those areas of the school that have risk, have chemicals, and have disposal waste for disposal. All of those folks need to work together with facilities to come up with a plan on how best to do that. This is also an area where you can work to minimize the waste that you're generating. Less waste, less regulation. Just kind of a fact of the way that the regulations are written. So if you can eliminate hazardous waste or reduce the quantity, it's going to save a lot of money. It's also going to minimize risk. Air monitoring is in section 16. This is really critical for those of you that have things like in science, your fume hoods. And then also, I see this as a concern in a lot of art classrooms. And I would encourage you to address it in those art classrooms. We have learned more and more of the risks associated with things like silicates from working with ceramics and glazes. So we need to make sure that we're implementing the best practices and the most important, or the best options for air emissions and for removing those materials away from us so that we don't have exposure problems. Section 17 gets a little confusing. It's a medical program. And basically this states that if you suspect that you've had any type of chemical exposure and it's detrimental, that you have a right to be medically evaluated to determine whether or not you have specific injuries or health issues associated with that exposure. When you write that, I would encourage you to take a look at a lot of different chemical hygiene plans and how they're written. This one requires some states, an evaluation of the state specific requirements as well. This one you need to ask for a little help on. All right. So strategies to get this done. We want to use the existing resources as a model. Predominantly, we want to really use that main chemical hygiene plan template. That's an excellent option for you. Identify an engaged team that's going to work together to make sure that this happens. Work with your administration so that they understand why these things are required and how best they can support you in making sure that you're working in as safe of an environment as possible. Make sure that if you do use a template that you make it site specific. It's got to be applicable to your particular risks and your particular chemicals. And while OSHA only requires that chemical hygiene plan to be for lab chemicals, other state agencies now require those for facilities. Once you've identified a chemical hygiene officer, please work to support that person. It's a really, really difficult job in a school district. It's hard to get right. And it's challenging because as a chemical hygiene officer, you have to ask a lot of hard questions. Do you really need to do this? Is there something else you can do as an alternative? How can we minimize risk to students? Keep in mind that all of us have the same goals. We want to teach good quality education, and we want to keep students and employees safe. All right, we've seen several cases where facilities gets dumped on with chemicals. So next time we're going to talk about facilities specifically, what role facility typically plays in waste disposal, and then strategies to minimize risk. So that if you're the facilities person and you walk into your office and here are 4 or 5 nice little bottles of brown, who knows what, sitting on your desk, how do we prevent things like that from happening so that you are not exposed? So please encourage your facilities person to attend our next webinar. And then steps to take that you can take today. Take a look at your lesson plans. Make sure that you include 2 additional sections in your lesson plans. One on the safety requirements when you're doing that lesson. And then also you want to button things up and include disposal requirements for any waste that's generated. Those are frequently 2 sections that are not included in lesson plans. So I'm going to push you a little bit and say you need to include those as well. So again, we want to include safety requirements if we're going to conduct, how we're going to conduct the lesson, and then waste, how are we going to handle that once it's been generated. Identify a team that can get your chemical hygiene plan done. Identify your chemical hygiene officer. And then assist that chemical hygiene team, your safety team, assist them in whatever way you can. Remember, it's a tough job. And then we want to continue to focus on that RAMP messaging from ACS, American Chemical Society. Recognize, assess, minimize, and prepare. Focus on minimizing your risk for the next week. And then next week, we will be discussing facilities roles in disposal and how we can keep facilities personnel safe. All right, here's contact information for me. You've got my email, you've got my web address, phone number, and you're more than welcome to reach out if you have any questions specifically. Also, if you have a hard time finding that template, that chemical hygiene plan template from Maine, if you have troubles finding that, reach out to me and I'll send it over to you. I'll send you over a link. Okay, do we have any other questions for today? I apologize, I went a couple of minutes over. What do we have for questions today? I know this was a really, this is a tough topic. This is as tough as going through the regulations for waste disposal. This is another very tough topic. So I know I told you a lot of things that probably aren't real popular today. What I'm going to encourage you to do, though, is just take it a piece at a time. The chemical hygiene plan template that Maine has offers you the opportunity to break it up into different chunks, and I would encourage you to attack it that way. All right, any other questions? Okay, thank you so much for your time today. I know this is a lot to have you miss an hour of class. I do truly appreciate it. And if there's anything that you need, any guidance, any questions you might have that come up later, please reach out to me, okay?
Thank you, Becky.
All right, thanks.